The universe begins not with sound, but with silence. Before the first light, before the first vibration of existence, there was an infinite stillness, so vast, so complete, that even the concept of before had not yet found meaning. In that unbroken quiet, time did not flow, because there was nothing yet to measure. Space did not stretch, because there was no distance to cross. What existed then was potential, sleeping within itself, waiting for the first breath of becoming. Imagine a canvas so absolute in its emptiness that even darkness had not yet been born. This is the prelude to creation, the long inhale before the universe began to sing. From this endless stillness, something stirred. Perhaps it was not an explosion, as our minds so often imagine, but an awakening, a sudden realization of energy that had always been there, now aware of itself. A whisper of possibility unfolded into motion, into heat, into time. The first moment, if we can call it that, was not the sound of thunder but the birth of separation between what was and what could be. The great silence fractured, and in that fracture, existence found its beginning. It was not chaos, not yet. It was rhythm, soft and tender, like the first note of a song that does not know its melody but trusts that it will come. As expansion began, energy unfurled across the void, painting a new reality into being. The universe grew, stretching into form, into space, into distance. Every direction became a direction for the first time. The stillness was no longer perfect, but it was beautiful in its imperfection, a universe awakening to its own breath. The cosmos began to cool, and from that cooling, structure began to whisper into existence. Particles emerged from the soup of pure energy, tiny sparks of identity in a sea of becoming. Each one carried within it the ancient memory of that first silence, as though the universe had written into every atom the remembrance of its own birth. For millions of years, the newborn cosmos was a dim, glowing fog, a haze of particles suspended in expanding time. It was not yet light as we know it, but the faint afterglow of creation's breath, a cosmic heartbeat echoing outward. In that dimness, energy and matter began a slow and patient dance. Gravity, the gentle hand of the universe, began to gather what was scattered. It pulled threads of hydrogen together, weaving the first seeds of form. These were not yet stars, not yet suns, but the promise of them, a potential waiting to ignite. The universe was learning how to build, how to balance, how to dream in matter. And still, silence reigned between these gatherings. Vast reaches of space remained empty, untouched by light, waiting their turn to awaken. The young cosmos was patient. It knew that to rush creation would be to spoil its beauty. There was no hurry, for time itself had only just begun to move. In that endless patience, energy cooled further, forming the simplest and most faithful element, hydrogen. It filled the universe like a soft mist, the breath of existence made tangible. Every future star, every planet, every being yet to come, would be born from this quiet substance, forged in the first stillness. Billions of years later, we would look up into the night sky and call it darkness. But this darkness was never empty. It was the cradle of everything that would ever be. The silence before light was not a void but a womb. Out of its quiet depths, the first sparks of creation would someday bloom. When we gaze into the blackness between stars, we are not looking into nothingness. We are looking into the ancient memory of the cosmos before it learned to shine. We are looking into the place where we, too, began, before atoms, before time, before the concept of us had meaning. To listen to that silence is to remember our oldest origin. The atoms in our bodies were once part of that formless calm. The quiet before the first star still hums in the spaces between our thoughts. Every breath we take carries an echo of that still beginning. The universe was once a thought not yet spoken, and in a way, we still live inside that unspoken thought. Before suns, before galaxies, before even light itself, there was the promise of awakening, and that promise is still unfolding in us. The embers before dawn still glow, faint and eternal. The same cosmic silence that preceded the first sunrise whispers within the rhythm of our sleep, in the quiet between our heartbeats. We are not separate from that stillness. We are its continuation, its echo, its dream. From the silence came energy. From energy came stars. And from stars came the question that lives in every human mind. Where did we come from, and what ancient fire burns within us still? In that question, the universe continues to awaken, slowly, softly, endlessly.
In the vast calm after creation's first light, the universe exhaled and cooled. Out of that quiet breath came something astonishingly simple, an element so pure, so unassuming, that it would one day shape everything we know. Hydrogen, the first true whisper of matter. It emerged not as a burst, but as a soft unfolding, tiny particles of protons and electrons finding each other in the slow grace of cooling space. Before hydrogen, there was only energy and motion. With hydrogen came identity, structure, and the first language of existence. It was the beginning of material reality, the first step toward all stars, planets, and life. Hydrogen is, in many ways, the universe's heartbeat. It carries the memory of the Big Bang in every atom, a living remnant of that original fire. Though it is the simplest of all elements, just one proton, one electron, it became the foundation for everything more complex. It filled the universe like invisible mist, a breath spread thin across unimaginable distances. In this era, there were no galaxies yet, no suns, only clouds of hydrogen stretching endlessly in every direction, shimmering faintly in the afterglow of creation. Each particle drifted in patient solitude, waiting for gravity's invitation to gather, to embrace, to begin the long journey toward light. Gravity, the silent sculptor of the cosmos, began to draw these clouds together. Slowly, over millions upon millions of years, hydrogen clung to hydrogen, folding inward under its own delicate weight. The universe was still young, but it was already learning the art of creation through unity. In the heart of these growing clouds, pressure began to rise. Particles collided, warmth accumulated, and the faintest whisper of light began to stir in the depths. Hydrogen, under enough pressure, could do something miraculous. It could fuse. It could become helium, releasing pure radiance in the process. This was not just a physical transformation. It was the moment the universe learned how to shine. But that first fusion had not yet begun. We stand now in the story's quiet middle, when hydrogen was everything, and yet it was waiting. Imagine oceans of gas, vast enough to swallow entire galaxies, slowly swirling through the black, each particle unaware of its destiny, yet drawn inevitably toward the gravity that would one day ignite it. These clouds were the seeds of suns, the unborn hearts of future galaxies. Within them slept the potential for warmth, for worlds, for consciousness itself. Hydrogen was the breath held between exhale and flame, the promise of light held in infinite stillness. There is poetry in hydrogen's simplicity. It is the smallest atom, yet it holds the largest dreams. Without it, no star could ever live, no planet could ever form, no living thing could ever take a single breath. Even now, most of the universe is made of hydrogen. It is the quiet majority, the soft background from which all brilliance rises. In a way, it is the soul of the cosmos, humble and unseen, yet ever present. Every atom of hydrogen carries a story written in time itself, the story of patience, transformation, and rebirth. It does not rush. It drifts, it gathers, it waits. And in that waiting lies the secret of everything that comes after. As hydrogen clouds thickened, faint ripples began to form through them. These ripples, born from the earliest tremors of creation, guided the gathering of matter, drawing more and more hydrogen into knots of density. The invisible threads of gravity connected these knots like constellations yet to be born. Slowly, the universe took shape. For the first time, structure appeared, a rhythm of density and emptiness, like the slow beating of an enormous heart. It was through hydrogen that the universe learned its first pattern, its first form of self-organization. It was not chaos, but choreography, a gentle dance in the dark. And within that dance, the seeds of stars began to stir. In the densest regions, where the pressure grew immense, hydrogen began to dream of fusion. Temperature rose. Motion quickened. The gas that once drifted aimlessly now moved with purpose, spiraling inward, compressing under its own gravity. Somewhere, deep within one of these clouds, the first flicker of light was preparing to awaken, a single atom fusing with another, releasing energy for the first time in the universe's history. That moment would mark the birth of the first star, and with it, the beginning of cosmic history as we know it. But before that awakening, there was only hydrogen and its infinite patience. If the universe could speak, perhaps hydrogen would be its first word, simple, singular, and filled with quiet promise. It is the language of beginnings. In its humble structure, it carries the potential for every chemical bond, every heartbeat, every breath of wind. It is the first alphabet of matter, spelling the name of creation across billions of light years. Even now, when we look at the night sky, what we see shining in the stars is hydrogen's story unfolding, its endless cycle of burning, fusing, and transforming into something more. The light of every sun is the voice of hydrogen, speaking through the ages. And perhaps there is something human in that simplicity. Like hydrogen, we begin small and unassuming. We gather experiences, pressures, and collisions, and in time, we ignite. We, too, are built from the same patient element that waited billions of years to shine. The hydrogen in our blood and breath once floated through the void, untouched by light, waiting for gravity's call. It is the same hydrogen that burned in the first stars, that became the building blocks of life, that now flows through us as memory. When we breathe, we continue the work it began, transformation, connection, becoming. So the breath of hydrogen still moves through us, across all time. The same substance that filled the newborn cosmos fills the air we inhale tonight. We are not separate from that first element. We are its continuation, its living echo. When we breathe, the universe breathes. When we dream, the universe dreams through us. The breath of hydrogen was the first whisper of creation, and through every heartbeat, it still speaks. The universe had waited long enough. For hundreds of millions of years, hydrogen drifted through the dark like a sleeping sea, silent, invisible, patient. But slowly, gravity's pull began to tighten its invisible fingers around the great clouds of gas that filled the newborn cosmos. They began to fall inward, drawn by their own growing weight. The dance that had once been slow and delicate became urgent, spiraling, alive. The clouds twisted and collapsed, compressing hydrogen into tighter and tighter spheres. Pressure mounted, temperature soared, and then, somewhere in the depths of that collapsing darkness, a miracle occurred. A single atom of hydrogen fused with another. Energy erupted, not chaos, not noise, but light. The first star was born. That first light must have been unimaginably beautiful. After hundreds of millions of years of cosmic night, a point of radiance bloomed against the darkness, a new kind of being, burning with purpose. One by one, others followed, like embers catching across the universe's vast, cold ocean. The era of darkness ended, replaced by the era of illumination. The universe, for the first time, had eyes that glowed. These first suns were massive beyond anything that exists today. Giant furnaces, short-lived and furious. They burned through their fuel in a few million years, a heartbeat in cosmic time. But in that heartbeat, they changed everything. They were the first to transform matter into light, energy into form, silence into song. These early stars, known to science as population 3 stars, were pure, made only of hydrogen and helium, untouched by heavier elements. Their purity made them wild and unstable, their cores burning hotter than anything that would ever follow. Their radiance flooded the cosmos, sweeping away the lingering fog that had shrouded existence since the beginning. The darkness that once defined the universe began to retreat, illuminated from within. Light was no longer a visitor. It had become a native of the cosmos. The first stars were the universe's declaration of being, its announcement that it could create beauty from emptiness. And yet, their brilliance was fragile. The very force that gave them life, fusion, also carried the seed of their destruction. These ancient suns consumed themselves at terrifying speed, converting hydrogen into helium, then into heavier elements like carbon and oxygen. In their hearts, a quiet revolution was taking place. The cosmos was learning alchemy. From simplicity, it was crafting complexity. From uniformity, diversity. In the heart of each star, nature was practicing the art of creation, an art that would someday give rise to planets, oceans, and life. Every flicker of their light was a promise of futures not yet imagined. The spaces between these stars began to glow faintly with their energy, forming the first galaxies, swirling families of light held together by gravity's unseen embrace. The cosmic darkness was now dotted with brilliance, each point a burning testament to the universe's capacity to create and destroy. But though they shone gloriously, these first stars lived in isolation. They were scattered across incomprehensible distances, separated by oceans of emptiness. Their light took millions of years to reach even their nearest companions. And yet, they burned for one another, weaving a web of radiance that slowly stitched the universe together. In those first stellar generations, creation and destruction were inseparable. The stars were fierce and immense, many hundreds of times the size of our sun. When they reached the end of their brief lives, their cores collapsed in on themselves with immense power. For an instant, gravity triumphed, crushing them beyond comprehension. But then, as if refusing to be silenced, they exploded outward in brilliant supernovae, scattering their enriched guts across space. In death, they fulfilled their greatest purpose. The carbon, oxygen, iron, and nitrogen that would one day make up mountains, oceans, and living things. All were born in that violent beauty. When we speak of fire on earth, candles, embers, the warmth of a hearth, we are speaking the language of stars. The flames we see are faint descendants of that first stellar burning. The atoms in our blood, our bones, our breath, once glowed in those first suns, before being cast across space in a billion glittering fragments. Those fragments drifted through the void, cooled, and gathered again into new clouds of gas and dust. The universe, having learned how to shine, now began to learn how to remember. But before rebirth could come, there was loss. As the first stars died, they left behind strange corpses, dense neutron stars, and sometimes black holes so powerful that even light could not escape them. Around these silent centers, the universe began to weave again. Gravity pulled the remnants of exploded stars together with the still living gas that surrounded them, forming new generations of light. The cosmos was recycling itself, turning ashes into energy, death into creation. This was the beginning of continuity, the first hint of the endless cycle that would one day define everything, from galaxies to hearts. In their brief lives, those ancient suns gave the universe its first structure, its first contrast of light and shadow. Before them, existence was a sea without distinction. After them, there were forms, points, patterns, relationships. They were not just stars, they were the architects of reality. Their gravity shaped the first galaxies. Their light seeded the first chemistry. Their explosions wrote the first laws of renewal. Without them, there would be no earth, no breath, no thought. Every element in our bodies, heavier than hydrogen, was once born inside a star like these, forged in fusion's quiet fire. If you could stand in that ancient universe, if you could somehow exist among those first suns, you would see something both terrible and tender. The night sky would blaze not with 1,000 stars, but with giants. Their light would pulse with the rhythm of birth and death. They would burn blue-white, hot and immense, yet fleeting, their lives a luminous sigh in the long silence of time. And as they faded, their ashes would drift, filling the cosmos with the dust of potential. It was from that dust that all future generations of stars, and eventually we ourselves, would rise. When we look at the stars tonight, we are looking at echoes of those first fires. Their light, though long extinguished, still lives in us. It pulses in every heartbeat, flows in every breath, whispers in every dream. The first stars awoke the universe from its long sleep. They were the first storytellers, the first witnesses to beauty, the first beings to burn. And from their brief and furious existence, all that followed was born. We are, each of us, the memory of their light, the continuation of their fire. The night sky is not a void, it is a reflection of that ancient awakening. And within it, the first stars still burn. In the hearts of the first stars, something sacred was happening, something that would define the universe forever. Deep within their blazing cores, where gravity pressed harder than thought can imagine, and heat rose to unthinkable brilliance, the universe began to create itself anew. This was not chaos. It was art. It was alchemy. The simplest element, hydrogen, was being transformed, step by step, into everything that would ever exist. Out of pressure came fusion, and out of fusion came light. That light did not just illuminate space. It illuminated possibility. In the quiet furnace of stellar hearts, matter learned how to change, how to evolve, how to become more than it was. Hydrogen fused into helium. Helium fused into carbon. Carbon into oxygen, neon, and magnesium. Each transformation was a note in a symphony that the universe had only just begun to compose. Inside every star, this music of creation played silently, ceaselessly. The process was both violent and delicate, an eternal balancing act between gravity's pull and energy's push. If gravity ever won completely, the star would collapse. If fusion ever outpaced it, the star would explode. But in that fragile equilibrium, perfection existed. Stars were not static things. They were living processes, continuous conversations between destruction and creation. Every atom that fused was both an ending and a beginning. The beauty of this alchemy lay not only in its power, but in its humility. From simplicity came abundance. From two lightest elements, hydrogen and helium, came the ingredients for everything more complex. The carbon of our bodies, the oxygen we breathe, the calcium in our bones, the iron in our blood. Each element was born in heat and light, in pressure and collapse. The stars did not choose what to make. They simply followed the rules written into the fabric of the cosmos, rules older than time itself. Yet through those rules, beauty was inevitable. The same equations that govern fusion also wrote poetry in the form of life and consciousness. As stars aged, the layers within them grew like the rings of a tree. Each layer carried a different element, each one forged from the ashes of the one before. Hydrogen burned at the surface, helium deeper inside, carbon and oxygen deeper still. The star became a cathedral of creation, with each shell representing a chapter in the story of transformation. And when it had exhausted its fuel, when it could fuse no more, the entire structure would collapse inward and then explode outward, scattering its treasures into space. Those treasures, those atoms of carbon, oxygen, and iron, became dust, drifting through the void until gravity found them again. Thus began the cycle of rebirth. This process, stellar nucleosynthesis, is one of the most profound truths ever discovered by science. It tells us that the matter composing everything we love was once forged in the core of a star. Every sunrise, every mountain, every heartbeat is an echo of that process. When we look at the stars, we are not looking at strangers. We are looking at ancestors, giant, radiant beings who lived and died so that we might exist. Their light, though ancient, continues to travel across space and time, carrying within it the memory of its origin. In every photon that reaches our eyes, there is a whisper of that ancient alchemy. The light of those stars carried more than energy. It carried information. Embedded in its wavelengths is the signature of the elements that produced it. When astronomers study that light, they can read the composition of distant suns as if reading a language written in color. Red lines for hydrogen, blue for helium, green for oxygen. Each shade a message from the past. The universe is not mute. It speaks in spectra, in radiation, in rhythm. Light is its diary, and through it we have learned to read our own history. The alchemy of light is not just physical. It is communicative, connective, eternal. What is most wondrous about this process is how inevitable it seems. There is no will, no design, only the natural unfolding of physics. And yet, out of that inevitability arises beauty that feels almost intentional. The universe creates because creation is what happens when energy and matter dance together. The stars do not know they are making life possible, but they do. They do so with every breath of fusion, every collapse, every burst of radiation. Their deaths sow the seeds of new beginnings. Their ashes become worlds, oceans, trees, and eyes that one day look back at them and wonder. In this, the line between science and poetry dissolves. Light itself is the purest record of this process. It travels endlessly, untouched by time, carrying the memory of its birth. The light that touches your skin tonight may have begun its journey before the earth even existed. It has crossed the gulf of the cosmos, bearing news from a star that has long since died. It carries warmth, yes, but also story. It carries the whisper of atoms that once burned in creation's furnace. It tells us that we are connected, not metaphorically, but literally, to everything that has ever shone. We are living in the afterglow of the universe's first dream. If you close your eyes and imagine the life of a star, it feels strangely familiar. There is birth, an expansion into brightness, a steady rhythm of giving energy to the world, and then a graceful decline, followed by transformation. We live as they live in miniature. We burn, we create, we exhaust, we become something new. The same laws that governed their shining govern our own being. We are made of their remains, and we live out their pattern in our own small way. To exist is to shine and to fade, to give and to return. That is the cosmic rhythm written in every atom. In the end, the alchemy of light is not just about physics. It is about meaning. It tells us that creation and destruction are not opposites. They are partners. One makes room for the other. The death of a star makes possible the birth of a planet. The fading of light makes way for new eyes to see. The universe is not a story of competition, but of continuity. In its grandest fires and quietest shadows, it follows a single principle: to become, to transform, to remember. And so, when you gaze at the night sky, you are not looking outward. You are looking inward, into the ancient fire from which your own atoms once burned, and from which your consciousness now glows. The alchemy of light continues in you. The first stars lived quickly and died beautifully. Their lives were brief, measured not in billions of years like our gentle sun, but in millions, mere cosmic heartbeats. They burned with such intensity that they could not last, yet it was their very fragility that made them sacred. When their fuel ran out, they did not fade quietly into darkness. They died in fire. The universe, once silent and still, now thundered with explosions of unimaginable power. These were the first supernovae, the deaths of giants, the cataclysms that would transform everything. In their destruction, the first stars gave back everything they had created, scattering their newly forged elements into the endless dark. Out of their death, the universe learned how to begin again. A dying star is not an ending, but a transformation. Deep within its heart, fusion pushes as far as it can go, up to iron, the element beyond which no more energy can be drawn from creation. When a star can no longer support its own weight, gravity claims its due. The core collapses inward with astonishing speed, shrinking from millions of kilometers across to just a few dozen in a fraction of a second. Then, rebounding from that collapse, the outer layers are hurled outward in a vast explosion of light and matter. For a moment, a single dying star outshines an entire galaxy. The light from such a death can travel across billions of years, illuminating worlds that do not yet exist. And within that light is the secret of all future life. When those first stars died, they did more than scatter dust. They seeded the cosmos with possibility. Before them, the universe was composed almost entirely of hydrogen and helium, the simplest and least varied of elements. After them, there was diversity. Carbon, oxygen, nitrogen, silicon, and iron, all were born in their fiery ends. These atoms became the raw material for everything to come, for rocks and rivers, clouds and cells, breath and thought. The explosion of a single star could scatter enough matter to one day form thousands of planets. Out of destruction came creation. The cosmos was writing its first great paradox, that death is not the opposite of life, but its essential partner. For a time, the universe must have glowed with ghostly brilliance. Supernovae erupted like cosmic storms, their light rippling through the interstellar gas. Each explosion sent shockwaves that rippled through the surrounding hydrogen, compressing it, stirring it, awakening it. The dust of the dead stars mixed with the untouched gas of a living universe, creating clouds rich in heavy elements. These clouds would someday collapse again, forming new stars, smaller, steadier, and longer-lived. In their hearts, the cycle would begin anew. The cosmos had discovered a rhythm: birth, death, renewal. It was learning how to sustain itself through endings. And in that rhythm, a new kind of beauty emerged. The early universe, once stark and simple, began to bloom. Galaxies took form, swirling islands of light. In their spiraling arms, stars were born and died in endless succession, each generation leaving behind the material for the next. The deaths of the first suns were not tragedies, they were gifts. They gave the universe structure, chemistry, and the ingredients for complexity. Without them, there would be no planets, no oceans, no life. The iron that runs through our blood, carrying oxygen from breath to cell, was once at the heart of such a dying star. The calcium in our bones, the carbon in our skin, all were forged in that long-ago fire. To live is to carry their ashes. Yet there is something deeply human in the sorrow of their ending. We understand the inevitability of loss, even as we find beauty in it. A star that burns too brightly cannot last, and yet, without its brief brilliance, the cosmos would remain barren. There is wisdom in that. Perhaps creation always requires sacrifice. Perhaps all light must, at some point, consume itself. The first suns gave everything they had. They spent their lives transforming simplicity into complexity. And when nothing was left to give, they offered themselves entirely to the future. Their death was the universe's first act of generosity. When the light of a supernova spreads across the void, it becomes a message. For billions of years, it travels, crossing silent distances, carrying the story of its origin. When that light finally reaches our eyes, it is more than photons, it is memory. We are witnessing an event that happened long before Earth existed, long before even the Milky Way was fully formed. In every glimmer of starlight, we see both the past and the promise of what that past made possible. The universe is, in a sense, still glowing with the embers of its own ancestors. After each explosion, what remained of the star varied. Some left behind dense, spinning neutron stars, cores packed so tightly that a teaspoon of their material would weigh more than a mountain. Others collapsed completely, vanishing into black holes, regions of space so curved by gravity that not even light could escape. These strange remnants became new players in the cosmic story, shaping galaxies, bending light, influencing the paths of stars. Even in death, the first suns continued to guide creation. Nothing in the universe was wasted. Everything was repurposed. Over time, the space between stars filled with more and more of this stellar debris. The universe, once clear and simple, became rich and complex. Dust clouds formed, made of elements that had once been fire. In these clouds, the potential for new stars was born, but now those stars would inherit the ashes of their predecessors. The cosmos had entered a new phase of its evolution, one in which memory was written into matter itself. Every new generation of stars carried within it the legacy of those that came before, a continuous lineage of transformation. When we gaze at the night sky today, we are looking at that lineage. Every star we see is the descendant of those first suns. Their ashes built the foundation of everything, galaxies, worlds, and the minds capable of wondering about them. Their death created us. It is a quiet thought, but a powerful one, that the end of one kind of light allowed another kind to be born, the light of awareness, of reflection, of life that can know itself. In their deaths, the first stars made room for consciousness to emerge. Their final act was to give the universe eyes with which to see itself. And so, when we look into the deep black of space, when we see those distant pinpoints of light, we are not looking into emptiness. We are looking into the remains of an ancient cycle that continues within us. The atoms of our bodies were once suspended in those supernova clouds, waiting for their turn to live. The death of the first suns was not the end of creation. It was its continuation. In every heartbeat, in every breath, the universe still echoes that first explosion. We are the quiet aftermath of brilliance, the dust of dead stars dreaming itself alive. Long after the first stars burned out and scattered their luminous ashes across the cosmos, a new kind of beauty emerged, one that was quieter, colder, and infinitely patient. Across the dark stretches of space, their remnants drifted like ghostly veils, clouds of dust and gas, faint and weightless, suspended in the eternal black. These clouds were not dead things, but memory itself, fragments of fire cooled into shadow, each grain a record of an ancient sun's final breath. This was the dust of creation, the soft residue of destruction, and it filled the galaxies like mist after rain. From a distance, it seemed like emptiness, but in truth, it was potential dreaming. This dust was made of everything the first stars had created: carbon, silicon, iron, oxygen. Each particle a tiny relic of cosmic alchemy, floating endlessly through the void. To human eyes, such dust would appear invisible, lost between the stars. But to the universe, it was treasure. It carried within it the raw materials of life, the ingredients of worlds yet unborn. The cosmos was becoming fertile, rich in complexity. What had once been only hydrogen and helium had now diversified into the full language of elements. The universe, once simple, had learned to remember, and that memory was written in the drifting dust. In the silence of interstellar space, these particles wandered for millions, sometimes billions of years. They passed through regions of radiation and magnetism, through cold and through emptiness. Sometimes they gathered together in faint, diffuse clouds, great tendrils of matter stretching across light years, shaped by the invisible hand of gravity. These were the interstellar nurseries, the wombs of galaxies. Within them, everything that would ever shine, or live, or move began as dust suspended in darkness. It was in these ghostly clouds that the next generation of stars would one day ignite. The cycle of life was not a straight line. It was a spiral, a pattern of death becoming birth. The dust carried echoes of its origins. When astronomers study it today, they find traces of the same elements that make up our own bodies: carbon chains, organic molecules, crystalline minerals. Some of these particles were forged in supernova explosions, others condensed from the gentle winds of dying stars. Together, they formed a cosmic mosaic, a gathering of fragments from countless stellar lives. If you could hold a single grain of that dust between your fingers, you would be holding the memory of 1,000 suns. Each tiny speck is ancient beyond imagination, older than any world, older than the very concept of time as we understand it. But these ghosts of dead stars did not wander aimlessly. Gravity, subtle yet persistent, began once more to weave its quiet spell. In the densest regions of the galaxy, the drifting dust and gas began to gather again, drawn together by the same force that had ignited the first stars. Over eons, vast clouds condensed, their particles colliding and clinging, warmed by friction, bound by attraction. Slowly, invisibly, the next generation of suns was forming. It is a strange and tender thought that the death of one star becomes the womb of another. The universe wastes nothing. Every end becomes a beginning written in the language of dust. The interstellar dust did more than build stars. It became the painter of the cosmos. When light from distant galaxies passed through these clouds, the dust absorbed and scattered it, reddening it, softening it, turning it into a cosmic haze. It is because of this that the universe has texture and depth, that distant starlight shimmers like a memory half forgotten. Dust gave the cosmos its atmosphere, its mystery. The galaxies no longer looked like sterile fields of light. They became living, breathing entities, veiled, layered, full of hidden stories. Through dust, The universe learned subtlety, shadow, contrast. Through dust, it became beautiful. There is poetry in this transformation. The same material that once burned in the cores of stars now floats silently between them. The same elements that once blazed with unimaginable heat now drift at temperatures near absolute zero. Fire became silence. Light became darkness. Energy became memory. This is the cosmic paradox, the way creation and destruction fold into one another until they are indistinguishable. The ashes of the first suns are not gone. They are merely sleeping, waiting to ignite again. The dust is not a remnant. It is a promise. In time, this dust would begin to gather into denser forms, into disks around young stars, into the seeds of planets, moons, and comets. But that was still far in the future. For now, the universe was content to rest. The great clouds floated through the galactic arms, glowing faintly in the light of nearby stars. Occasionally, a passing photon would strike a dust grain, warming it slightly, causing it to release a faint infrared whisper, a gentle radiation, the sound of the cosmos dreaming in its sleep. If the universe had a lullaby, this would be it, the quiet warmth of dust remembering the fire from which it came. Even now, billions of years later, that dust remains. It drifts between the stars, unseen but ever present, forming the fine threads that connect all things. When we gaze at the night sky and see the soft glow of the Milky Way, we are seeing not just starlight, but also the light that has been filtered, softened, and shaped by dust. The darkness between the stars is not empty. It is full of history. Every shadow, every faint band of light across the sky, carries the memory of ancient suns and the quiet promise of those yet to come. And within us, too, that dust endures. The calcium in our bones, the carbon in our cells, the iron in our blood, all were once part of those drifting clouds. We are, in the truest sense, the ghosts of stars, given form for a time. The dust that wandered through the void found a way to awaken, to see itself, to wonder. It dreamed of becoming light again, and through us it does. Every thought we have, every heartbeat, is that same cosmic dust remembering what it was, and what it will be again. The ghosts in the dust are not gone. They live in the wind, in the oceans, in the eyes that look toward the night sky. The universe is haunted not by what it has lost, but by what it continues to create. In the quiet spaces between the stars, in the thin, shimmering clouds that span light years, existence gathers itself once more. Out of stillness comes motion. Out of shadow comes fire. And from the dust of what has died, life begins to dream again. Out of the great silence of dust and darkness, the universe began again to gather its strength. The ashes of the first suns had drifted long enough. Now in the slow, invisible pulse of gravity, they began to move, drawn together, woven into vast, cold clouds that would one day bloom into light. These were the molecular clouds, immense and delicate, stretching for hundreds of light years. They were the hidden gardens of the cosmos, places where creation prepared itself in secret. To the human eye, they would seem like nothing, black shapes blocking the stars. But inside them, the quiet work of rebirth had begun. Within these clouds, the temperature fell close to absolute zero. Hydrogen atoms paired together, forming the simplest molecule in the universe, H2. These molecules clung to dust grains, cooling them further, helping the cloud collapse under its own weight. Here and there, faint ripples disturbed the stillness, shock waves from distant supernovae, the passing of nearby stars, the gentle turbulence of galactic rotation. Each disturbance was a whisper that stirred the slumbering gas, awakening gravity's touch. Slowly, parts of the cloud began to contract. What was once vast and diffuse started to condense into tighter knots, hidden within the dark. As gravity continued its patient work, the density of these knots increased. The dust grew thicker, the gas more crowded. At first, nothing visible happened. No light, no sound, only the slow, inward drift of matter. But within those invisible centers, pressure was rising. The atoms, crushed together by the relentless pull of gravity, began to move faster, to collide more violently. The temperature climbed. What had once been cold and inert was beginning to stir with energy. The quiet darkness was preparing to ignite. There is a moment in the birth of a star when potential becomes inevitability. The cloud cannot resist itself any longer. The inward fall accelerates until the very heart of the forming sphere grows hot enough for fusion, that sacred process that first gave light to the cosmos. Hydrogen atoms merge to form helium, releasing energy, and for the first time in eons, light returns. A new star is born. The darkness of the nebula is pierced by a faint, glowing ember. It begins small, gentle flickering. But it will grow. Around it, the dust swirls in graceful arcs, forming disks, spirals, filaments. The ashes of ancient suns have become the seeds of a new generation. From one cloud, dozens, even hundreds of stars may emerge. Some will be massive and bright, destined to live fast and die young. Others will be smaller, steadier, the ones that will endure. Around them, the remaining dust and gas begin to form into thin, spinning disks, the cradles of future planets. Already, the cycle is repeating. Birth, transformation, dissolution, rebirth. The cosmos breathes in long, slow rhythms, measured not in moments, but in epochs. Each new sun that flares to life carries within it the atoms of the ones that came before. The universe has learned to recycle itself endlessly, turning memory into flame. Inside the glowing cradle of a nebula, chaos and beauty coexist. Winds from newborn stars sweep through the cloud, carving caverns of light and shadow. Radiation ionizes nearby gas, causing it to shine in vivid hues: pink from hydrogen, green from oxygen, blue from helium. These colors are not random. They are the fingerprints of creation, the visible language of the elements themselves. From Earth, we see them as the great nebulae, the Orion, the Eagle, the Lagoon, vast blossoms of color scattered across the night sky. But to the stars within them, these clouds are wombs, warm, turbulent places where gravity and heat negotiate the boundaries of existence. It is a quiet miracle, this process that repeats across the cosmos. Every star, no matter how distant, begins in the same way, from a whisper of dust, from the faintest collapse of a forgotten cloud. There is no urgency in this creation. It unfolds at its own pace, guided only by balance and persistence. If the collapse happens too fast, the cloud tears itself apart. Too slow, and it never ignites. The universe is patient, and in that patience lies its artistry. The birth of stars is an act of precision as much as passion, an equilibrium of forces so delicate that even a small change would alter the destiny of entire galaxies. And yet, it happens endlessly. Across the Milky Way, in every spiral arm, thousands of stars are being born at this very moment. Their light will not reach us for centuries, but already they are shaping the future. Around some of them, disks of gas and dust are beginning to flatten, to warm, to clump together. Tiny grains collide and stick, forming pebbles, rocks, and then worlds. It is in these thin disks, circling young suns, that planets find their beginnings. The material that once drifted cold and aimless in the dark now finds itself drawn into orbits of order and purpose. The chaos of dust becomes the geometry of worlds. And perhaps, within this cycle, there is something of the human story as well. We, too, are born from clouds of memory and chance, drawn together by invisible forces, collapsing inward until something within us ignites, a consciousness, a spark. We live, we burn, we fade, and the material of our lives returns to the larger whole. The birth of stars is not only a physical event, it is a metaphor for all becoming, all awakening. Out of darkness, light. Out of dust, fire. Out of stillness, motion. The cosmos mirrors us because we are made from it, its dust, its flame, its longing to shine. Even now, in the deepest regions of the Milky Way, this process continues. Whole constellations are forming unseen, still wrapped in veils of dust. Their light will take millions of years to reach us, and by the time it does, the stars themselves may already have changed, evolved, or died. Yet the light will keep traveling, carrying their memory forward. The universe's story is not one of endings, but of persistence, of creation that survives through transformation. The stars we see tonight were born from death, and someday they too will die to give birth again. In the end, this is how the cosmos endures, not through permanence, but through renewal. Each collapse becomes a new expansion, each death a new beginning. The birth of stars is the universe's most ancient heartbeat, echoing through time, reminding us that nothing is ever truly lost. It merely changes form. The dust becomes flame, the flame becomes dust, and through that endless exchange, the universe keeps dreaming itself into being. The new stars were still young, fragile flames flickering in the immense dark. Around them, the remnants of their birth clouds lingered, forming vast, swirling disks of gas and dust. These disks, glowing faintly in the starlight, were the cradles of worlds. Every planet that would ever exist began as a swirl of matter around a newborn sun. Within those thin rings of chaos, the universe prepared its next act of creation, a quieter, slower process than the violent birth of stars, yet no less profound. It was here, in the stillness between collisions, that the architecture of future worlds began to take shape. The process was almost invisible. Tiny grains of dust, the same carbon and silicate particles that had drifted through the galaxy for billions of years, began to collide. Sometimes they stuck together, bound by static electricity, by gentle adhesion, by the shared will of gravity. Most collisions ended in destruction, the particles shattering apart again. But a few endured. Over time, they grew, millimeter by millimeter, pebble by pebble. What began as dust became clumps, then stones, then boulders. Within a few million years, the disk transformed into a swirling sea of debris, countless fragments colliding, merging, shattering, and forming anew. This was how planets began, not through sudden birth, but through patience, through persistence, through endless repetition. As these fragments grew, gravity strengthened its hold. Larger bodies began to attract smaller ones, sweeping up nearby material, clearing paths within the disk. These growing worlds in progress were called planetesimals, the seeds of planets. They orbited their young star like children learning to dance, each one pulled by the same rhythm, each one shaping the space around it. In time, collisions became less frequent, and growth more stable. The largest planetesimals became protoplanets, embryonic worlds, molten and chaotic, glowing with the heat of their own formation. They were not yet the serene orbs we know, but rather violent, storm-filled spheres, covered in oceans of magma, shrouded in gas and smoke. Creation, even at its most wondrous, was never gentle. Amid this turmoil, the architecture of entire solar systems took form. Some protoplanets grew massive enough to capture vast envelopes of gas, becoming giants, worlds of hydrogen and helium like Jupiter and Saturn. Others remained smaller, rocky, compact, like Earth, Mars, and Venus would one day be. Their fates depended on distance, temperature, and chance, on whether they formed in the inner warmth of the star's light or the frozen reaches beyond. Each system was unique, shaped by countless small accidents, each collision a decision written into cosmic history. The order we see today was born from chaos, sculpted by time and gravity into harmony. And around all of this, light moved softly, the golden glow of young stars reflecting off the dust, illuminating the edges of the disks. From afar, these regions appeared as faint halos of light in the dark, protoplanetary nebulae, nurseries of creation still wrapped in mystery. Even now across the galaxy, billions of such disks exist. In each of them, new worlds are forming, some destined to orbit peacefully, others to collide and vanish before they ever see light. The process is universal and eternal. Every spark of light in the night sky may be surrounded by unseen worlds in the making, worlds we will never know, but that carry the same cosmic legacy as our own. But in these disks, something extraordinary also began, the slow formation of chemistry, the quiet assembly of complexity. As temperatures shifted, as minerals condensed and metals cooled, molecules began to combine in ever more intricate ways. Simple compounds formed on the surfaces of dust grains, water ice, methane, ammonia, organic carbon chains. These were not yet life, but they were its prelude. Each molecule was a note in a silent cosmic symphony, a rehearsal for the music that would one day awaken on a distant shore. The same chemistry that would shape oceans and clouds, trees and breath, was already at work here, hidden in the spinning dusk of creation. The new worlds, once they formed, would carry this heritage forward. Some would be scorched, their atmospheres torn away by radiation. Others would freeze in eternal darkness, orbiting too far from their stars to ever see warmth. But a few, perhaps only a handful in each galaxy, would find balance. They would orbit at just the right distance, where light and shadow meet, where water could flow, where air could hold the whisper of breath. These rare worlds would become the homes of life. From their dust and fire, the universe would learn to see itself, to dream, to question, to wonder why it exists at all. And yet, in this grand dance of creation, destruction was never far away. Planetary formation was a story of collisions as much as growth. Entire worlds collided, shattering into fragments, merging again into new forms. It was through these cataclysms that moons were born, that orbit stabilized, that balance emerged from chaos. The Earth itself, long before it cooled, long before oceans formed, was shaped by such a collision, a violent impact with a world the size of Mars. From that destruction, our moon was born, a silent witness to the violence that precedes harmony. Even beauty, it seems, must pass through fire. Over the next hundreds of millions of years, the newborn worlds cooled. The dust cleared. The stars settled into stability. Around them, systems of planets moved in graceful order, their paths defined, their fates sealed by gravity's calm hand. The chaos of the early universe gave way to rhythm, to structure, to the quiet breathing of a cosmos that had finally learned the art of balance. What had begun as formless dust had become a universe of orbits, tides, and seasons, a cosmos capable of stillness and reflection. In this moment, somewhere, in one such disk of dust and gas, a small, yellow star flickered into steadiness. Around it, 8 planets began their long revolutions. One of them, small and unremarkable, carried the right balance of light and dark, warmth and cold. Upon its molten surface, the dust of the first stars cooled into stone, and from that stone, mountains would rise, oceans would form, and eventually, life would awaken. The star would come to be known as the Sun, the planet Earth. And though countless others had come before, this one would, in time, begin to wonder where it came from. When we look back upon this story, we see that our world is not an exception, but a continuation, a single verse in an ancient cosmic poem. The same dust that once drifted through the void, the same atoms that once burned in the hearts of dying stars, found their way here, into our oceans, our skin, our breath. Planetary formation was not merely a mechanical process. It was the universe learning to compose. It was the moment when matter began to find meaning, when gravity and chemistry joined hands to write the prelude to life. And so, the cosmic story deepened. Stars were no longer alone. Around each one, silent companions revolved, planets, moons, rings, comets. In the quiet that followed creation's storm, the newborn worlds began to cool. Their fiery beginnings faded into stillness. The molten seas hardened into stone. The churning atmospheres began to thin and settle. The young sun, no longer a restless flame, shone with steady warmth. Across the inner solar system, the violence of formation gave way to the long patience of time. Yet even as the planets found calm, the story of Earth was only just beginning. Out of rock and silence, something astonishing would arise, not suddenly, but with the subtlety of breath forming in the cold. The universe, through this small blue world, was preparing to know itself. The early Earth was not yet the gentle home we imagine. Its surface boiled beneath a sky of volcanic smoke and vapor. The young sun burned brighter now, and the last fragments of its birth cloud still drifted through space, occasionally raining fire upon the planet. Asteroids and comets fell from the dark, delivering water, metals, and the strange organic compounds forged in the ancient cold. Each impact was both destruction and gift, erasing what had formed, yet seeding what would come. Slowly, the Earth's crust thickened. Volcanoes breathed out steam and carbon dioxide. And over millions of years, the sky, once thick with ash, began to clear. The cooling continued. Steam condensed, and rain fell, perhaps for centuries, without pause. Oceans gathered in the hollows of the world, filling valleys and plains, carving out the first continents. The surface that had once been molten now shimmered beneath clouds of silver gray, reflecting the young light of the sun. And beneath those waves, where minerals dissolved and molecules drifted, the first whispers of chemistry began to hum. The stage was set for the universe's next miracle, the transformation of matter into life. In those ancient oceans, lightning flashed across the sky, striking the surface of the water and splitting molecules apart. The energy of storms drove new combinations into being: amino acids, simple sugars, fatty chains. These were not yet alive, but they were precursors, notes of a melody that had not yet been written. Over time, these molecules gathered into membranes, into droplets that could grow, divide, and react. Within them, chemistry began to organize itself, guided not by chance alone, but by the quiet logic of physics and energy. The line between the living and the non-living began to blur. No one knows exactly when the first true life arose. Perhaps it happened in deep-sea vents, where heat and minerals created endless opportunities for transformation. Perhaps it began in shallow pools warmed by sunlight, where cycles of evaporation and condensation forced molecules to build complexity. Wherever it began, life was not a sudden arrival, but a slow awakening. The universe, through the medium of water and time, had found a way to turn its own dust into thought. What had once been the ashes of stars now pulsed, replicated, and evolved. It was the first time that matter learned to persist through self-renewal, a small echo of the cosmic rhythm itself. These earliest organisms were simple, single cells, no larger than dust grains, yet infinitely more intricate. They fed on minerals, on sunlight, on the chemical gifts of their world. They were fragile, yet they endured. Over hundreds of millions of years, they multiplied, diversified, learned to shape their environment. They invented photosynthesis, turning sunlight into energy and releasing oxygen into the air. The Earth's sky, once thick and toxic, began to clear and glow blue. Slowly, the planet transformed. Life had begun to alter the very nature of its home, guiding it toward balance, toward beauty. All of this was made possible by the same cosmic history that preceded it. Without the supernovae that had forged carbon, oxygen, and nitrogen, life could not have formed. Without the dust that cooled into planets, there would be no oceans, no continents. The atoms that now danced in the chemistry of life were born in the hearts of ancient suns, scattered by their deaths, gathered again by gravity, and shaped into the fabric of a world. Life, then, was not a separate phenomenon. It was the continuation of the same process that had begun with the universe itself. Creation had simply changed form, moving from stars to cells, from light to consciousness. The young Earth breathed in rhythm, with its Sunday days lengthened. Seasons began. The planet learned the slow language of rotation and orbit. In the interplay of warmth and cold, of sunlight and shadow, evolution found its pace. Time itself became the sculptor, chiseling possibility from randomness. From the simplicity of cells came colonies, from colonies came cooperation, and from cooperation came complexity. The ocean floor teemed with unseen life, an entire world in miniature, rehearsing the patterns that would one day fill forests, mountains, and skies. And yet, even as life flourished, the memory of the stars remained within it. The energy that fueled every cell came from the sun, a continuation of the same fusion that had burned in the first stars. The atoms of every organism still carried the legacy of those long-dead suns. When a cell divided, when a leaf opened to the light, when a creature took its first breath, it was the universe remembering what it had once been. energy transformed into form, chaos finding order, dust becoming self-aware. The oceans became the cradle of diversity. Over billions of years, new forms emerged, simple at first, then intricate, graceful, astonishing. Life learned to swim, to photosynthesize, to breathe. The atmosphere filled with oxygen, transforming the color and texture of the planet. From the interplay of rock and water, sunlight and shadow, something profound was taking shape, a biosphere, a living skin upon the face of the earth. And within it, every organism, no matter how small, carried within its body the elements of ancient suns. It is a humbling thought that every living being is a mosaic of stellar memories. The iron in our blood, the calcium in our bones, the oxygen in our breath, all of it was once inside a dying star, scattered across the void, gathered again in the swirling disk of a newborn sun, and finally assembled into a world that could dream. When we look up at the stars, we are not gazing into something foreign or distant. We are looking into the mirror of our own origin. The cosmos and life are not separate stories. They are one and the same, a continuous unfolding of matter toward awareness, of darkness toward understanding. And so, from the cooling of a planet to the flicker of a cell, the universe crossed another invisible threshold. It had moved from creation to consciousness, from physics to biology. The fire of the first suns had found a new expression, not as light alone, but as life. And within that life, a deeper light began to stir, the faint awareness that would one day look back upon the stars and ask where it came from. In the silence of the early earth, beneath the endless wash of rain and the shimmer of lightning, the first living things drifted in the sea. They did not yet see or feel or think, but in their small, chemical hearts, the pattern of all future minds was already written. The dust of the stars had finally learned to dream. Life, once it awakened in the oceans of the young earth, began its patient, quiet work of shaping the planet. For hundreds of millions of years, single-celled organisms drifted, multiplied, and evolved, nearly invisible to the eye, yet monumental in their significance. Each tiny life form was a laboratory of chemistry, a vessel of possibility. They experimented, adapted, and transformed the environment around them, altering the composition of the oceans and the air. Slowly, imperceptibly at first, these early beings began to prepare the earth for complexity, for the coming explosion of life that would fill seas, lands, and skies. They were the universe's first storytellers, writing narratives in molecules, in energy, in the very breath of the world. Through photosynthesis, some of these cells captured sunlight, transforming it into chemical energy, and released oxygen into the oceans. That oxygen, once a dangerous novelty, slowly accumulated, reshaping the planet. It reacted with minerals, formed new compounds, and eventually filled the atmosphere. The Earth's skin, which had been heavy with gases like methane and carbon dioxide, began to turn blue. Clouds became lighter. Rain became purer. The oceans carried new chemistry, and in this transformation, the stage for multicellular life was set. The universe had learned another subtle lesson, that even the smallest agents, given time and opportunity, can change the face of worlds. The rhythm of evolution unfolded without hurry, but without pause. Genetic material, small and mutable, carried the memory of trial and error across generations. Mutations, rare and random, became experiments in adaptation. Over eons, these experiments gave rise to new structures, new abilities, and new ways of interacting with the environment. Life began to diversify, forming branches that stretched in countless directions, some destined to flourish, others to vanish without trace. Yet every failure, every extinction, contributed to the shaping of what would survive. The process was patient, persistent, almost meditative, a slow unfolding of possibility guided by natural laws rather than intention. By the time the first multicellular organisms appeared, the oceans had become a rich canvas. Algae, soft-bodied animals, and primitive plants flourished. Predation and cooperation emerged, introducing dynamics of interaction that would drive complexity forward. Simple ecosystems formed, small but interconnected, each organism affecting others in subtle ways. The Earth was no longer merely a passive stage for life. It had become an active participant, a co-creator in the dance of evolution. Its chemistry, temperature, and orbit intertwined with biology, each shaping the other. Life was now a force capable of altering the very planet it inhabited. The emergence of multicellular life brought new possibilities. Organisms could specialize, developing structures and functions that single cells could not achieve alone. Limbs, sensory organs, circulatory systems. These innovations expanded the reach of life, allowing it to explore new environments, to adapt to challenges, and to inhabit niches previously inaccessible. Each innovation was a quiet triumph of chemistry and physics, a solution written in the language of matter and energy. Life was learning, slowly but irreversibly, how to interact with the world beyond itself, how to leave traces upon the very surface of the planet. Over the vast spans of time, life ventured onto land. Simple plants, stretching toward the sunlight, transformed the atmosphere further, adding oxygen, stabilizing soils, and capturing energy. Insects, amphibians, and early reptiles followed, adapting to air, gravity, and temperature in ways unimaginable to their aquatic ancestors. Each step required courage against the indifferent forces of physics, against desiccation, heat, cold, and predation. Life learned resilience and innovation simultaneously. Every adaptation was a message sent forward in time, a note in the universe's growing symphony of awareness. By the time the first forest rose, oxygen levels had climbed high enough to support enormous insects and other life forms. Earth had begun to breathe as a living system, cycles of photosynthesis and respiration interweaving into planetary rhythms. Ecosystems became intricate networks of interdependence. Life was no longer just surviving, it was orchestrating. Microbial communities shaped soils. Plants stabilized landscapes. Predators maintained balance. Evolution had transformed simple chemistry into complex relationships, demonstrating the subtle intelligence inherent in natural processes, intelligence that required neither consciousness nor intent. Throughout this long, quiet epoch, extinction and renewal walked hand in hand. Mass extinctions, often brutal and sudden, cleared spaces for new forms to emerge. Each cataclysm, though destructive, ensured that evolution's path remained dynamic, ever-changing. Life was resilient because it was adaptable, and it adapted because the universe had made it from the same elements that had survived the deaths of countless stars. In this way, the cycle of birth, death, and rebirth, first observed in the heavens, now played out on the surface of a small, spinning world. The echoes of supernovae were still present in the rhythms of evolution. As eons passed, organisms became more complex, more aware of their environments, more capable of interaction and response. Nervous systems emerged, allowing sensation and reaction. Eyes opened to light, ears tuned to vibrations, bodies learned to move with intent. Life was no longer passive chemistry. It had become a network of perception and action. It was beginning to experience itself, and through that experience, to leave traces in the fabric of Earth. The seeds of consciousness, subtle and tentative, were being sown in the nervous tissue of the first sentient organisms. And somewhere within this unfolding, the universe's ancient alchemy, the transformation from hydrogen to stars, from stars to dust, from dust to planets, from planets to life, reached a new threshold. Life had begun to understand itself, at least in the most basic sense, through adaptation and survival. It was a continuation of the cosmic story, long-awaited awakening of matter into awareness. The atoms that had once burned in the hearts of the first suns were now engaged in the slow process of experiencing, interacting, and evolving. The universe, through life, was beginning to look back upon itself. This was the quiet majesty of early life, persistent, patient, transformative. It worked not with haste, but with the slow certainty of time. Through chemistry, biology, and countless iterations of trial and error, life carved patterns into the world, leaving subtle traces of its presence. It altered the atmosphere, shaped the terrain, and created the preconditions for even greater complexity. In doing so, it mirrored the larger cosmos. The same forces that guided the birth and death of stars now guided the birth and evolution of life. The cycle of creation, destruction, and renewal continued, linking the heavens to the oceans, the dust of distant suns to the cells of Earth's first living things. As life continued to evolve on Earth, a quiet transformation began to take shape, one that would ripple through oceans, forests, and skies for millions of years. From the first nervous systems emerged creatures capable of sensing the world around them, responding to light, heat, and vibration. Simple reflexes became complex behaviors, and through these interactions, life began to record memory, the faintest hint of awareness. Evolution was no longer merely chemistry. It had become experience. The universe, through this small planet, was beginning to perceive itself, experimenting with perception on scales both microscopic and monumental. From the depths of the seas to the shallow waters near the coasts, life flourished in new ways. Coral-like organisms built reefs, creating shelter and structure for other species. Tiny predators learned to hunt with precision, while prey evolved strategies to evade them. Every action had consequences, shaping not just individuals but entire ecosystems. The Earth itself responded. Oxygen levels fluctuated with the growth of photosynthetic organisms. Nutrient cycles intertwined with climate and geology. Life and planet were no longer separate. They had become partners in a delicate, ongoing negotiation, co-creating an environment in which complexity could thrive. Then came the age of the great colonizers, plants, fungi, and eventually animals venturing onto land. It was a perilous journey. Gravity, dehydration, and ultraviolet radiation posed challenges that life had never faced. Yet, slowly, organisms adapted. Simple mosses and algae anchored themselves to soil, drawing nutrients and stabilizing surfaces. Insects and other arthropods followed, exploiting new niches, pollinating early plants, and linking food webs in ways that had no precedent in the ocean. Life was learning to occupy space in 3 dimensions, to shape itself around gravity, atmosphere, and the rhythms of day and night. The Earth was becoming more alive, more textured, more capable of supporting further complexity. The rise of vertebrates marked another turning point. Fish developed more efficient circulatory and respiratory systems, allowing greater mobility and endurance. Amphibians began the first tentative steps onto land, adapting to both water and air. Reptiles soon followed, their scaly skin protecting them from desiccation, their metabolism attuned to the sun's warmth. Each adaptation was a small triumph, a response to both opportunity and constraint. Life was not random. It was shaped by the persistent pressures of environment, energy, and survival. And in these pressures, the seeds of intelligence and coordination quietly began to take root. Predation and competition became the sculptors of form and function. Every organism that survived was a product of countless failures and adaptations before it. Armor, speed, camouflage, flight. These traits emerged not by design, but through repetition, refinement, and selective pressure. Life was learning to anticipate, to respond, to act with cause and effect. It was gaining the capacity to influence its own fate in subtle ways. And with each evolutionary success, the stage was set for even greater leaps. Creatures with enhanced perception, communication, and coordination. Forests rose, vast and teeming with life. Trees towered above the ground, drawing sunlight and storing carbon, shaping climate and habitats alike. Underneath, fungi formed networks that linked roots, exchanged nutrients, and communicated subtle information between plants. Insects buzzed, pollinating flowers and ensuring the perpetuation of species. Birds took to the sky, reptiles sprawled across the land, and mammals began their slow, hidden ascent. Complexity was no longer confined to individual organisms. It emerged in ecosystems, in interactions, in feedback loops that bound life into a living system. The planet was awakening into a dynamic, conscious interplay of forces. The oceans, meanwhile, continued to teem with life, both ancient and newly evolved. Cephalopods, fish, and marine reptiles developed strategies to hunt, evade, and thrive. Coral reefs and kelp forests became intricate webs of interdependence, each organism a thread in a vast tapestry. Even microorganisms, invisible to the naked eye, orchestrated biogeochemical cycles, regulating oxygen, nitrogen, and carbon. The same processes that once governed the birth of stars now govern the flow of energy through life. Fusion of potential into action, transformation of one form into another, persistence through interaction. Throughout this era, mass extinctions punctuated the steady rhythm of evolution. Each cataclysm, whether caused by volcanic activity, asteroid impacts, or climate shifts, cleared ecological space, resetting the stage for new forms to emerge. Destruction, once again, became the prelude to creation. And life, resilient and persistent, responded by diversifying in astonishing ways, exploring new forms, behaviors, and habitats. The echoes of cosmic cycles were visible in these patterns: birth, growth, death, renewal, repeated over and over, across scales both vast and intimate. And in the midst of this unfolding, the first sparks of higher intelligence began to emerge. Neural networks became more complex, sensory organs more refined, social behaviors more sophisticated. Some creatures began to learn from experience rather than instinct alone. They began to perceive patterns, anticipate consequences, and communicate in rudimentary ways. The universe, through Earth, was testing the possibility of self-awareness, a consciousness capable of reflecting upon itself and its place in the cosmos. Evolution was no longer solely about survival. It was now preparing the canvas for thought, curiosity, and wonder. By the time mammals and birds emerged in the wake of the great extinction that ended the reign of the dinosaurs, the Earth had become a vibrant, layered world. Forests, oceans, skies, and rivers were filled with life capable of movement, perception, and interaction. Complex behaviors had emerged: hunting in packs, building shelters, nurturing offspring, forming social bonds. Every new ability was a subtle echo of the cosmic pattern, the same rhythm that had governed stars and dust: transformation, adaptation, persistence. The universe, it seemed, was preparing for something profound. Creatures capable of asking the very questions we now ask. Life had become the mirror of the universe itself. The slow, patient forces that had transformed dust into stars, stars into planets, and planets into living matter were now shaping perception, cognition, and consciousness. Each organism was a note in a grand symphony, a reflection of cosmic processes rendered in flesh, blood, and thought. And within the symphony, the stage was set for the emergence of beings who could wonder about their origins, gaze at the stars, and trace themselves back to the ashes of long-dead suns. Thus, the story of life on Earth became a testament to continuity, to transformation, to resilience. From single cells to sprawling forests, from oceanic microbes to soaring birds, life mirrored the cosmos itself. Persistent, adaptive, endlessly creative. The Earth, once molten and chaotic, had become a living, breathing system, ready to host awareness, capable of reflecting upon the universe that had made it. And in this reflection, the universe glimpsed itself, first faintly in the smallest neurons, then more clearly with each passing generation, moving ever closer to consciousness. In the long sweep of Earth's history, life had learned to shape itself and its surroundings with subtlety and precision. Forests and plains, rivers and mountains, all became arenas for interaction, competition, and cooperation. Yet, within this web of life, a new phenomenon began to emerge. Creatures capable of reflection, of memory, of foresight. Their minds, small at first, were sensitive to patterns, to cause and effect, to the rhythms of day and night. Evolution had not only sculpted bodies, but also consciousness itself, preparing for a leap that would eventually bridge the distance between the material world and the realm of thought. The first mammals were quiet, unassuming creatures, yet their brains harbored a remarkable potential. Sensitive whiskers, acute hearing, and refined instincts allowed them to navigate their environments with nuance. They observed, learned, and remembered. across generations, these abilities intensified, allowing species to develop strategies for survival that were increasingly sophisticated. Predators planned hunts. Prey developed foresight. Early social behaviors emerged, the rudiments of communication, cooperation, and empathy. Life was no longer merely responding to circumstance. It was beginning to anticipate, to shape its own fate. This period of evolution was marked by both patience and experimentation. New forms arose, thrived, and sometimes vanished. Yet each attempt left a legacy encoded in DNA, a memory carried forward. Nervous systems grew more intricate, capable of integrating sensory information, processing memory, and coordinating complex behaviors. Creatures became aware of each other in new ways, recognizing kin, detecting threats, and even displaying curiosity. The Earth was no longer simply a backdrop for life. It was a partner in a growing consciousness. The planet itself, shaped by tectonics, weather, and oceans, provided the medium in which cognition could expand. With the rise of primates, these capacities took another step forward. Eyes capable of depth perception, hands capable of manipulation, and social structures that encouraged cooperation and learning converged to create beings that could observe not just the immediate, but the abstract. They could imagine, remember, and plan. The subtle spark of awareness began to transform into a broader intelligence, one capable of linking past, present, and potential future. In these early primates, the universe was preparing for the first conscious questions about its own existence. Social behavior became a crucial driver of this developing consciousness. Groups formed, alliances were made, hierarchies negotiated. Communication grew more sophisticated, relying on gestures, vocalizations, and subtle signals. Within these interactions, individuals learned from one another, transmitting knowledge across generations. Culture, in its most rudimentary form, had arrived. Life was no longer purely genetic. Experience could now ripple outward, shaping the survival of communities. The planet's living network had become self-reflective, capable of both learning and teaching. Meanwhile, the Earth itself continued to evolve in tandem with its inhabitants. Climatic shifts, tectonic movements, and the rise of mountains and rivers provided challenges and opportunities. Life responded, adapting to new conditions, exploiting niches, and innovating solutions. Species became specialists, generalists, explorers, and builders. The coevolution of mind and environment created feedback loops. As cognition expanded, life altered the planet. As the planet changed, life adapted. Consciousness was not born in isolation. It emerged from the dynamic interplay of organism and world, each shaping the other in a continuous dialogue. The emergence of tools marked another profound leap. Early primates discovered that objects could be used to extend their influence, to manipulate environments in ways that natural anatomy alone could not achieve. Stones, sticks, and simple implements became extensions of thought, a bridge between mind and matter. By experimenting, observing, and repeating, these early beings began to externalize intelligence, encoding memory and intention into the physical world. This was the first step toward technology, toward shaping not only immediate survival, but the broader trajectory of life itself. Curiosity, the quiet engine of this transformation, drove individuals to explore, to test boundaries, to question cause and effect. It was a subtle force, often invisible, yet immensely powerful. Those who observed patterns in seasons, behaviors, or celestial movements could anticipate events and adapt. Knowledge accumulated not just in genes, but in culture, in habits, rituals, and communication. Slowly, life became capable of abstraction, of imagining things beyond immediate perception. The universe, through these creatures, had begun to recognize its own rhythms. With this growing awareness came reflection on mortality, on risk, and on consequence. Early primates observed life and death, birth and decay, success and failure. These observations, encoded in memory and reinforced through social learning, created an emergent understanding of the fragile balance of existence. Life had begun to glimpse its own temporality, the inevitability of change, and the necessity of adaptation. Consciousness, it seemed, was inseparable from the awareness of impermanence. And then, as primates evolved into hominins, intelligence began to scale. Brain size increased, neural connections multiplied, and cognitive capacities became more intricate. The foundations of language, planning, and abstract thought emerged. Humans began to manipulate fire, craft tools with intention, and develop symbolic systems. They could remember the past, anticipate the future, and most remarkably, imagine worlds that did not yet exist. Life, which had once been the silent unfolding of molecules and cells, had now achieved a new dimension: self-awareness and imagination. In this way, the universe had completed a long arc, from the birth of stars to the awakening of mind. The same processes that forged elements in stellar cores, that scattered dust across galaxies, that guided the evolution of oceans and continents, now guided the emergence of consciousness. The atoms of ancient supernovae, the dust of countless stars, were now enmeshed in thinking brains capable of questioning their origins. The Earth itself had become a mirror, reflecting the cosmos not just in its forms, but in the awareness that now dwelt within one of its species. The story of life and mind on Earth is the continuation of cosmic cycles. Fire becomes dust, dust becomes life, life becomes consciousness. Each stage echoes the previous, reflecting a universe that seems to fold upon itself, constantly learning, adapting, and remembering. In the quiet forests, rivers, and plains, the universe whispers its ancient truths through the thoughts, actions, and curiosity of its most aware creatures. Consciousness is the latest chapter in a story that began long before Earth existed, a delicate yet profound manifestation of the universe's desire to know itself. And so in these earliest humans, in their observations, in their questions, in their dreams, the cosmos found a voice. It was subtle, nascent, and fragile, yet it carried the weight of eons. Through them, the universe began the quiet work of understanding its own story, tracing its origins from the ashes of long-dead suns to the living, breathing world beneath their feet. Life and mind had intertwined, and in their union a new awareness dawned, one capable of asking not just how, but why, and beginning to seek the answer. The emergence of early humans marked a profound turning point in the story of life on Earth. For the first time, beings who carried the atoms of ancient stars could reflect, imagine, and wonder. They observed patterns in the world around them, anticipated the cycles of nature, and began to manipulate their environment with intention. Fire became a tool not just for warmth, but for transformation, shaping materials, guiding survival, and marking the first conscious interaction with the world. Language emerged as a quiet bridge between minds. Sounds carried meaning, stories preserved memory, and knowledge began to ripple across generations. Humans no longer depended solely on instinct or heredity. They could teach, learn, and imagine futures. Early storytelling, myths, and rituals allowed them to externalize thought, to see themselves as part of a larger unfolding. These stories were echoes of the cosmos, attempts to capture the invisible rhythms of stars, the cycles of life, and the flow of time. Tools and observation became extensions of thought. Stones shaped into implements, patterns in the stars traced and recorded, and careful attention to the land allowed humans to survive and thrive. They began to link past, present, and future, noticing cause and effect in ways no other species had. Consciousness, once subtle and emergent, became deliberate. Humans could not only react, but reflect, ask questions, and imagine possibilities beyond immediate experience. In this awareness, the universe found a mirror. The atoms that once burned in dying suns now flickered in thinking minds. Humans became participants in a long cosmic story, capable of tracing their origins, feeling awe, and beginning to understand their place in the vastness of time and space. Through observation, creativity, and reflection, they began to hold the universe within themselves, becoming the first conscious witnesses to a story billions of years in the making. Humans, emerging from the lineage of life, began to glimpse the vastness of the cosmos that had given them form. The night sky, once a silent canvas, became a mirror reflecting their own origins. They noticed the patterns of stars, the movement of planets, the waxing and waning of the moon, and in these rhythms, a sense of order began to emerge. Observation became a tool not just for survival, but for understanding. Each discovery, the path of the sun, the phases of the moon, the rise and fall of seasons, connected human experience to the eternal cycles of the universe. With the advent of mathematics and measurement, humans could interpret the movements of celestial bodies, predict their rhythms, and begin to grasp the vast scales of time and space. The universe, once distant and unknowable, revealed its structure. Humans realized that the atoms in their own bodies were forged in ancient stars, that the dust of long-dead suns had gathered to form the ground beneath their feet, the water they drank, and the air they breathed. In understanding this, humanity began to see itself not as separate from the cosmos, but as a continuation of it, a conscious thread woven from the same elements, carrying forward the memory of creation. Through observation, imagination, and reflection, humans became the universe's eyes and voice. Astronomy, philosophy, and culture intertwined, allowing awareness to expand outward into the heavens while deepening inward into thought and creativity. Humans learned to connect matter, life, and consciousness into a single, unfolding story. The stars, which had burned and died long before Earth existed, were now reflected in human understanding, and through that reflection, the cosmos began to know itself. Each insight, each question, each act of curiosity was a continuation of the universe's long journey, from fire to dust, from dust to life, and from life to conscious awareness. And now, as we reach the quiet culmination of this long journey, we can pause to reflect on the remarkable story that has unfolded across billions of years. From the fiery death of ancient stars to the formation of planets, from the slow assembly of molecules to the first flickers of life, and from the rise of consciousness to the emergence of human awareness, the universe has been patient, deliberate, and endlessly creative. Every stage has been a transformation, each moment a step along a continuum that stretches from the dawn of matter to the capacity to question, to imagine, and to wonder. Humans, fragile and fleeting as they are, embody the culmination of forces that began in the heart of the cosmos. The atoms that make up our bodies were once fused in the cores of stars, scattered across galaxies, and gathered again to form the solid ground beneath our feet, the oceans in which life began, and the very air we breathe. Consciousness, imagination, and curiosity are the universe's own reflections, unfolding within a single species on a small planet, offering a way for the cosmos to see itself. Every thought, every observation, every story we tell is a continuation of the cosmic narrative, an echo of events that began long before Earth existed. In this realization, there is both humility and wonder. We are not separate from the universe. We are participants in its ongoing creation. Our awareness allows us to trace the lineage of stars in our own bodies, to feel the rhythms of matter and energy that have persisted across eons, and to perceive the delicate balance that sustains life on Earth. Each breath, each heartbeat, each act of reflection is part of this vast, interconnected story. The cosmos is not distant or indifferent. It is alive in us, in the very molecules that remember the fire of stars long extinguished. And yet, even as we contemplate this continuity, we are reminded of the fragility and impermanence that has characterized every stage of existence. Stars die, planets shift, species vanish, and civilizations fade. Life itself is a brief flourish in the vastness of time, a fleeting pulse of consciousness in the silent expanse of the cosmos. And it is precisely this impermanence that gives meaning, depth, and beauty to the journey. The universe, in creating beings capable of reflection, has also created witnesses, creatures who can marvel at the fleeting brilliance of existence, who can honor the processes that made them possible. As we look outward into the night sky, we see stars that have long since perished, their light traveling across unimaginable distances to reach our eyes. In that light, we witness our own past, a story intertwined with cosmic events, a narrative that spans time and space. And as we look inward into the complexity of our minds, the intricacy of life, and the legacy of our planet, we glimpse the universe in miniature, a reflection of the same forces, the same processes, and the same wonder that have guided creation from the beginning. In the quiet of this reflection, we can sense the profound unity of all things. The ashes of older suns, the swirling dust of protoplanetary disks, the first cells in ancient oceans, and the neurons firing in our brains today are all chapters in the same story. The universe has moved through fire, dust, water, and life, and in the end, it has arrived at awareness, a consciousness capable of tracing its own origins, of feeling awe, and of seeking understanding. In that consciousness, the cosmos finds itself. And so, as we close this chapter, we are left with a sense of quiet wonder. The journey from stars to life, from dust to thought, is not a story with a final conclusion, but a continuing process, a river flowing through time, shaping worlds, forming consciousness, and reflecting upon itself. We are part of that river, both its witnesses and participants, its creators and creations. In understanding this, we honor the lineage of stars, the persistence of life, and the gift of awareness. The universe began in fire, evolved through dust, gave rise to life, and now lives within our perception. In this endless continuity, we are not merely observers. We are the universe aware of itself. And in that awareness, the story continues quietly, patiently, and with infinite possibility.